First, can you explain for us what terraforming is and how we should think about it?
So terraforming is creating sustainable habitats and ecosystems beyond Earth. And so it includes local terraforming, which is, for example, a large dome or a large tent within which you can have a self-sustaining habitat, and also global terraforming, which would involve altering the climate of an entire planet. For example, Mars or Titan or
Okay.
Venus. Yeah.
Yep.
To give it surface temperature and pressure, allowing liquid water, and first microbial and eventually human habitability.
And is that something, this concept of terraforming, that's being seriously considered for Mars?
For at least 50 years. So the first NASA studies were in the mid-1970s, and then going on through the work of Carl Sagan and Chris McKay in the 1990s, people agreed that there were basically two stages if you want to do this, because it's a human choice whether we want to do it or not. First, you would need to warm the planet up to allow simple forms of photosynthetic life. That's a relatively easy step and relatively quick. And then a slower and harder step, which is photosynthetic life builds up the oxygen level. This is an extraordinarily difficult task. We know that one planet has undergone that process, our own planet, Earth, but it occurred over geologic timescales. And so to accelerate it to happen on timescales relevant to human civilization is an extraordinarily difficult task. A minimum requirement for even contemplating terraforming is very low-cost access to space, which didn't exist until recently. It arguably doesn't exist even now. And so the science, the basic physics, chemistry, geoscience, ecology, is sort of dependent on the engineering to lower the cost of access to space to the point where some of these ideas can be feasible.
And so let's dig into what those ideas are. You and your collaborators have devised some theoretical ways you think we might be able to transform Mars. Tell us about those.
So to warm Mars up, you've got several options. You can create a stronger greenhouse effect. You can bounce sunlight down from orbit using mirrors, or you can darken the ground so that it absorbs more sunlight. And so one approach that we're looking at is have a greenhouse effect that's provided by basically engineered aerosols. So examples of aerosols are, clouds or haze or dust that would let sunlight through but trap the infrared and thus warm the planet. And this is a collaboration with Northwestern University, and it's funded by Astera Institute.
Okay. Who is able to make such a decision that terraforming is something that should be pursued?
All of us. So Mars is governed by the Outer Space Treaty, which everyone has signed up to. And the Outer Space Treaty says that the exploration and use of the celestial bodies, which includes Mars, shall be the province of all humankind. And so there would have to be international consensus before altering the environments of Mars. But I think it would be...
Well, it's kind of laughable in some ways, though. In theory, that sounds amazing, but especially if you think about the world that we're living in right now, the likelihood of getting alignment on something that significant, I wouldn't think is great. And then the propensity of somebody to take it on their own, or a country to take it on their own to do it, is probably not insignificant.
Or
is that cynical?
Well, we can look at our past track record. Most of Earth's surface is governed by international agreements. The biggest one is the International Seabed Authority, which governs something like 45% of Earth's surface, and organizes mining and allocates rights of various sorts, and distributes the proceeds to all countries, including landlocked countries. Another example is the Antarctic Treaty, which is held for, I guess, getting on for a century now.
Okay.
Origin at the same year as the start of the space age. Again, governs a large fraction of Earth's surface area, lots of countries have signed up, seems to have held up till now. Then the third example is the Outer Space Treaty itself. You could say it hasn't really been tested yet, but it exists, and it's the law in most countries, including our own.
And so do you feel that we will get to a point where there's going to be a decision put on the table that this is something that ought to be explored and for lack of a better word, voted upon?
I think we're very early stages of research, and a lot more research needs to be done. Mars is probably the easiest planet to terraform, but that's still very difficult to terraform. We don't have all the information we would need to feed into that decision or vote. So what is that information? Well, I think the first is a more intense search for life. Mars' surface sure looks sterile today, but there could still be life deep down, and there could have been life early on. And so we need more missions to look for deep aquifers, to return at least a soil sample from Mars. A second piece of information we need is more information about the climate change that Mars has already undergone. So climate feedbacks are a huge uncertainty for human-induced climate change. And in the same way, understanding the climate feedbacks that operate on Mars, so cloud feedback is important on both planets, will require studying the geologic record of Mars's past climate changes. And that will include access to ice cores, just as on Earth, and also more study of the sedimentary rock record. So I think many more exploration missions to Mars are necessary before the vote or the decision. And by the way, a lot of these missions are also needed for human exploration. So we're probably going to send humans to Mars. And to do that safely and sensibly, we need to know where the resources are that humans could use, the most important being water ice. So we know Mars has polar caps, but it gets really cold at the pole of Mars in the winter. And so the best place for an initial human mission is in the mid-latitudes, where there's some water ice, but it's still relatively warm. Understanding exactly where the ice is at the level of certainty that you need to send humans is also important for thinking about terraforming, because water ice is a resource for warming the planets and also for initial microbes.
Okay, gotcha. Do you see a period of time for your own research where you say that you expect the continuance of your career to be focused on Mars? Or do you feel there's a period where you'll get to and say, the things I wanted to learn, I've learned, and now I'm going to turn my attention elsewhere? How do you think about that?
Science is like, a brush fire. The frontier of human knowledge is always moving outwards. So it's just a question of how long before we figure out all that we can figure out about Mars, and our attention turns somewhere else as our instruments get better, our techniques dig deeper. So how long will that take? I don't know. I think we will need at least a dozen, more missions to understand what Mars has to tell us. One big gap in our exploration so far is we don't have much horizontal range. So we land at a point, and you've got to pick that point really well, because you only drive like 20 kilometers for the whole mission away from that point. That's very limiting. You've got a planet that has a land surface area equal to that of the Earth. Imagine if you applied that approach to studying the Earth. And so in that picture, I think the helicopters are extremely exciting. So we've flown one helicopter on Mars, Ingenuity, and it was a technology demonstrator, did fantastic, didn't do much science. A scaled up version of Ingenuity that can fly hundreds of kilometers or even thousands of kilometers, I think that could be transformative. The other thing that we haven't done is we haven't looked deep. We're looking at the rocks that are exposed at Mars's surface. Our radars can't penetrate deep within the rocks of Mars. But what you can do to explore deep is you can land and throw out a coil and then run an electric current through that coil. And that does electromagnetic sounding down on Mars. So that way you can find deep aquifers if they're there to be found. I think that would be really exciting. So I guess, Paul, my answer is yes and no. So yes, in principle, eventually we're going to figure it out. But I think it'll take a while to get there. And we need new tools to do so.